in general, if I just say that I do have a function, okay, and I say that this function can be, let's say, phi1, phi2, and so on. There will be infinite function part of these functions, and if I just really want to converge to this function, what we do is we just pick up summation of ci ix, okay, and the aim is to actually find out what is this constant. This is what we will see here. And if we actually have a very large value of these summed up results, we actually will approach or converge to fx. Now, why does that happen? This is something which we are going to see today with the help of an example. So this is actually a series, and if we just take up the sine term and the cos terms, okay, this is basically comprises the Fourier series. So it will always be provided with a limit, and that limit will be between minus pi and plus pi. And then the constants that we want to derive can be derived using this particular formula. So, if I just want to divide this series into its different parts, the first would be nothing but related with 1. So the constant is a0 by 2. And with the sine term, we have got a constant an and sine nx. Plus with the cos term, we have got the constant bm cos nx. Okay. And some books, as someone pointed out yesterday, you also have it written as cos nx and nx. There is nothing wrong in it. Okay, you can do it this way also. Same thing. Okay. Next, we have to find out what is a0, an, and bn. So for a0, we are going to use this particular formula. It's nothing but on top we have to take the inner product. Okay, on top we have to take the inner product between phi and f. And in this case, in the first case here, our phi is 1, and f will be this function. So we'll just take this to be 1 fx, and in the inner product we are basically taking an integration. So what we do is we take it from the limit, lower limit to the upper limit, minus pi to plus pi dx, divided by pi squared. So that means 1.1 inner product with itself dx. Just do it. When we do the denominator, we get it to be minus of 2 pi if we do the calculations correctly. Okay, and not minus of 2 pi, I guess it's plus of 2 pi. And on top it is fx dx, so fx dx. We've got 1 by 2 pi, that is a0 by 2, so 2 gets cancelled, I get the value of a0. So when we do actually Fourier series analysis, these are some of the results that we need to remember, and how we are going to use these results is something which we are going to look into today. We can also calculate we are going to get this result. Okay. And then we are going to again do it for bm, and then we are going to get this. So we have got a0, an, and bm. Okay, using the similar procedure, we have to be a bit more clear with the integration steps. Okay, we should know these steps. Okay, there is something which is expected that you know since you are class 12. Okay, based on this 3 results, we actually have got the constants a0, an, and bm. Okay, and if the limit changes, we have to just do certain replacements. In place of pi, we have to write down l. In place of minus pi, it will be minus l, and in place of x, it will be pi x divided. Actually also play around with the change in limits. But today we are not going to do anything with change in limits. Today we are actually going to do a problem where exactly we are going to use the Fourier series analysis. So let's take up this. So you might have also so let's say I have got a function. Let me use a different color. This is the function we have. This is the function. And if I just write it down here, I can take this to be, let's say this is minus pi, and this is, let's say, 0, and this is 1 pi. Okay. So if I just want to write down this function, the form of this function, I can just write this way. You can simply write it down to be fx is equal to 0, and when it is 0, when this value of x, okay, this is x, this is the x coordinate we have, when the value of x actually lies between minus of pi and 0. So if it is between minus pi and 0, this is 0, Okay, 0, you can see this is 0 on the 0 coordinate, and this will be actually 1, okay, when this x lies between 0 and pi. So this is the function that we have, and we are going to do a Fourier series analysis of this. Okay, so before we really understand that why we need to have a number of functions added up together so that this will actually converge to fx, we are going to solve this, and then we are going to understand it better. Okay, so for using the Fourier series, for doing the Fourier series analysis, we have to first find out the constants. Okay, so we do have the functions. Okay, if we just want to recall it once, we have the function, and this is nothing but a naught divided by 2 plus, and then we take a summation, let's say I, and then this is let's say a n, we have used the constant here, sine of nx dx plus summation of bn cos mx, right? Sorry, not dx. Integrating it here. Yeah, so this is the series we have, right? And the aim is to actually find out what is my a naught, what is my an, and what is my bn. That's the Fourier series analysis. And what we will see, that whatever result we get will be actually the general form of this function fx. And if we actually plot a graph, we are actually going to get this plot. Okay, and this is what is the aim. Now, there is always a doubt there. This is a sine function, this is a cos function. That means we are talking about a periodic function. So whatever may be the result will actually give me something like this. But this is not this. This is actually a straight line. So can we really represent this in the form of a Fourier series? Okay. So this is something which we are going to see now. Okay. Let's just solve it, the steps, and then probably we can understand it better. When you do it on your own, it will be even more clear. So let's just find out the value of a naught. So a naught is equal to 1 divided by pi, and then this is minus pi to pi fx dx. Okay. This is something which you already know. And when we actually have different limits, this is from minus pi to 0, and then this is 0 to pi. So we can separate out the integrals. So it is 1 by pi. This would be minus pi to 0 fx dx. Okay, I'm just doing it in detail so that all of us are on the same page, we understand it clearly. Plus 1 by pi, and minus pi to 0 we have done, then we are going from 0 to pi. Your fx is just 1, and then this is dx. Okay, so you can just do your integration here. 1 by pi into pi. If you do this integration, this should be pi, and the answer is 1. So that's my a naught, right? And let's just do an. Okay, an. So an would be nothing but 1 by pi. Okay, minus pi to plus pi. Okay, so if your mathematical skills are good, this is a paper where you can score, and it seems some of you are very comfortable with integration and differentiation, so that's good. Okay, it should be helpful. And then fx sine of nx dx, right? So this is the one. So as I said, that you need to remember the result. That's it. Okay, how you derived a naught, and bm doesn't really matter. Okay. So here also I can actually take it from minus pi to 0 and then 0 to pi. But minus pi to 0 will always be 0 because this function is 0. I don't need to consider that limit. I will just simply go from 0 to pi every time for this particular function. Now this is a step function. Okay, you can just check it. Fx is 1, and then this is a sine of nx dx. Okay, so you have to just do it. That's it. So you can do it as cos of nx, right, divided by n. Okay, there is no minus sign, right? And then you can write it down to be 0 to pi, and then I can take it to be minus of 1 divided by n pi. So this is something which you should remember here. Okay, this is cos of pi upper limit minus cos of 0. So this is something which I'd like all of you to pay attention. This is minus of 1 divided by n pi. Okay. And this cos of n pi can be written as minus 1 to the power n, right? Depending on whether the value of n is odd or even. Okay. So if n is 0, you have got cos 0. So this is minus 1 to the power 0. Anything to the power 0 is 1. So that's 1. And then you take this to be 1, let's say. So this will be minus 1. Cos of pi is minus 1 and so on. So this will basically continue. So you have to just write it down in this way, minus of 1. Okay. So this is the thing that you have to kind of remember. That will be important. Okay. And we can always take the minus sign inside, and then maybe we can just write it down in a better way. This will be 1 minus 1 to the power n. Okay, so that's my an. So that's my an. Okay, somehow my handwriting looks good today on this. Okay. So sheerly for the sheer love of writing, I'm just doing it. Okay. Okay. So BM निकाल लेते हैं. BM is 1 divided by pi. This I think we can, all of us can do it quickly. Okay. And then I will again take it to be 0 to pi. I'll just leave that other limit. Okay. I'm not going to repeat that. And then we have got fx cos of fx, right? So your fx is 1. Right. This is 1 in that limit. So that means I have to just integrate cos. So I will take it up here. And then I can just write it down to be sine of mx divided by m is 0 to pi. So it's a sine term, and you are taking up pi as the variable. So everything is going to be 0. Sine of 0 is 0. So this is 0. So everything is 0 here, right? So you have got a0, you have got an, and you have got bm. Now we can actually write down the Fourier series. Okay, and when we write down this, we are going to do a lot of analysis. That's actually easy. So it's all about integrating it correctly. Interpreting the result comes later. So it was a0 by 2, an0 was 1. So it is half plus, and then we do have a summation. And let me just take the summation over n, I guess. I think it will be easy. And we got it to be a0. We got, an, we got 1 by pi n. And then this was 1 minus 1 to the power n sine of nx. So if I'm asking you to actually solve it plus 0, because bm is 0. So if I'm asking you to basically solve it, okay, Fourier series analysis, find out the form of the function, you can actually stop here. Okay, I think that's okay. And of course, if you're just looking into the values here, you can explain that what happens when the case is odd, when n is odd, and when n is even, and so on. Okay. But then if it is asked, you can do it else, even if you don't explain it, that's fine. Okay. So usually when we do Fourier series analysis, this is the function that we are aiming for. So whenever you are actually plotting a graph, you know that graph will actually have some kind of function involved. That means I put a value of n and or x, and based on that I'm going to get the graph pattern. Okay. So if I just maybe just a small brief. Okay, it's not really needed to use in exams, but then I think you can understand this here. So if I just want to understand what is happening here exactly, this is your function. Okay, so this is the step function that you have. Now the problem here is that this is basically a sine function. So that means, let's say you are just taking up, let's say 10 values of n. 10 values of n. That means then now if you plot a graph, and in fact if you plot a graph, okay, you can use a the Microsoft Excel or any computer program to plot the graph if you don't want to do it physically, and then probably you're going to get something like this. Okay? Maybe something like this. I'm just giving an example. Okay, now this is actually following the path, but then it is not very close to the actual result. But then if n is very large, okay, on the other hand, if n is very large, so I hope you understand now that n is very large, that means this summation has to be very large. You're going to have an infinite number of terms, okay, just technically infinite number of terms, and have a very large number of terms. Then what will happen? You're going to have the sine curve. Okay, obviously this is not the right way. which will be very much close to this function, and this will almost be representing a straight line. Okay, and that is what is important here. Okay, so even if sine or cos is actually added, okay, and if it is not added in a large number, we are not going to get this step function. But if we have, sine and cos terms, okay, sine and cos terms added in large numbers, okay, added in large numbers, okay, this fx will be replicated over time. Okay, I hope you understand this. And that's why I told you that when you actually write down the function, and in general, we write it down as ci phi ix, which we have seen in the last class. We actually have n, or let's say I, maybe I can write down n here. This n is very large. If it is large, this is going to approach the function that we are actually trying to represent. So that's the importance of Fourier series analysis. Okay. So let's just do one more problem. You can do so many problems. There will be so many types of expressions that you are going to get. Okay. So before that, maybe I can do this one integration before we actually do the next problem, so that we can actually finish it faster. Okay, or maybe I can just give it to you as a task and you can do it. So you have 0 to pi. Okay, even if you don't remember, please try to recall this. Important sine of nx dx. It's basically a function, and you can have to integrate it. Okay, and you have to use the product rule. Okay, and the integration. You have got two functions here, x and sine. It's never too late. We can always start. So, right. If we just do this, you have to identify which function actually vanishes. If you remember, whatever you did in integration, you know that ddx of x will become 1, so that will vanish. We'll have a single function there, sine nx dx, right? So that's something which you should get, right? So if I do it, it will be minus of x, make a little, because even I need practice, cos of nx divided by n sine, so there is a minus sign, and this will be nothing but 0 to pi minus, this is ddx of x comes 1. If you integrate this, this is 0 to pi. Okay, and if you actually integrate this, you are going to get cos of nx divided by n dx, right? And then this is a minus here, so I can just take up this minus of 1 by n, and within bracket if I put the limit, upper limit, lower limit is 0, so if I put x is equal to 0, everything becomes 0, so I can just simply have it as pi cos of pi x, really, but minus, and then this will be nothing but 1 divided by n, and then we integrate this cos of nx, so it will be another n, so it will be 1 divided by n square. Okay, and then you integrate cos, sorry, there is a minus, when you do this, there is a minus here, so this will become plus, so it is 1 by n square, right? And then you can just do it as sine of nx, right? And this will be 0 to pi. So the second term, it vanishes, okay, and that's made the problem that you have not checked. This is pi, sine of pi is 0, sine of 0 is 0, so second term vanishes, so it becomes very easy now. Okay, so this is 1 by n, or pi, I can take it out, pi divided by n, and then cos of nx, as I said, it will depend, okay, what is the value of n here. It will depend on what is the value of n here, and so minus 1 to the power n, just like the previous problem. Okay, so we are going to just keep this result in mind, and we are going to do our next problem. Okay, so next problem will be again a kind of step function, but then the values of the limits are more or less different. Okay, just going to look into that next problem. So next problem, I'm just going to give it to you, and then you can actually apply it. Okay, so example 2. Fourier series is actually interesting. Okay, we're going to do this series expansion and all later. So fx is 0, and that's the same. The limit is the same here, just like the previous one. Minus pi to 0, and then this is equal to pi minus x. That's the limit that we have it between x and I. Okay. So you do it. Okay, you do it because I've already given you how to do it. Just do the calculations. Okay. And when you practice, the more you practice, it's better. When you practice, you'll see that there are a lot of things that you understand better. Okay, if you do it in detail, it's even better. I sometimes do it in detail. Prefer doing it in details. So how do you represent this function in a graph? Maybe something like this. Maybe this is the x-axis, and maybe this is minus pi to plus pi. And then we have got this. We do it. Just draw it like this. And then this is pi minus x. So it is basically nothing but in the form of y is equal to mx plus c, and having a negative slope. So I'll take it this way. So if we represent it, we will like this. Minus pi 0. Okay, maybe this is pi. This is the line that actually represents the second part. Pi minus x. A0 is equal to 1 by pi integration of, again, minus pi to 0 is 0, so anyway I'm not going to consider that. 0 to pi, and then pi minus x dx. So right, so to just do it, this will be 1 by pi, take the bracket, this is going to be pi into x minus of x square by 2 is 0 to pi. So 1 by pi, 0, forgot about it, it's going to be 0. So this is going to be what? Pi into pi square minus pi square by 2. So it is 1 by pi into pi square by 2. So this gets cancelled, so it is pi by 2. So that's my A0. So, all of us should do it individually. Practicing is important. Sometimes we actually just get carried away. We think that, okay, we'll do it directly in exams. That's where we actually fall. Make our faults, okay? Pi minus x sine of nx dx. And now I hope you understand why we did that previous thing. So this would be nothing but 0 to pi, and then this would be nothing but pi sine of nx dx, and then minus 0 to pi x sine nx dx. So
Sir,
we can
P
just
is
write
equal to minus 2 by pi m.
is equal to minus
2 by pi m sir. Equal to, sir वही है.
वही है
2
ना?
by
अच्छा,
pi.
2 by pi m square. Okay, maybe. Then maybe it's correct. Okay. So when you get more answers, similar answers in the same class, the chances are that it should be correct. Right. So this is a pi there, and then it is. So all of you should do it. Huh? It's very important. I'm doing it here, and just and the minus sign, and then 0 to pi.
Sir,
Yeah.
so at the time of examination, should we draw the curve for the functions given to us?
Not really. If it is asked, you can draw it. Maybe sometimes you will be given the curve, then you have to write down the function. Sometimes only the function would be given, the curve might not be given. So even if not asked, you don't need to draw the curve. So drawing the curve is actually not very important. Just to understand it from your point of view, that is important. Right? So we have already done x sine and x. I forgot the result. X sine n x 0 to pi is minus pi by n minus 1 to the power n. Right, so this is minus of pi by n and then minus 1 to the power n. This and this will get cancelled, this and this will get cancelled. Okay, so we should be getting it to be minus 1 divided by n, and then here we have got it to be pi हो जाएगा, so it will be minus 1 to the power n for this and minus 1. So we put one term here and then minus this is again 1 by n, so I can take up 1 by n here, and within bracket it's minus is there, so okay, so the plus here, yeah, and then this would be minus of 1 to the n. So there is a minus minus, it becomes plus. So if I'm doing it correct, so it will be 1 by n, I can take up, and then this is a minus, so I'll just reverse this. So it will be 1 minus 1 by n, and then we 1 by n taken out, so it will be plus of minus 1 to the power n. So yeah, cancel हो जाता है, it will be 1 by n. Okay, so that means this is also correct, right? So this is correct, this is also correct. However, I don't know. Maybe we can do it. So we are finding
Sir,
out.
is it necessary to, sir? Sir? Sir, is
Yeah,
it necessary to do this integration by parts method?
we can do it in any method we want, but you know, it's not mandatory, definitely, because it's not something which is a part of Fourier series. How you actually derive the result, that is more important. So yeah, by parts, even if you don't do it, it's fine. And you know, since we have done it here, sorry. We have done this so that we are actually just showing that what is the result, okay, by the simplest technique that we know. And when you do it in your exams, you know, it's expected that you actually give certain answers which should be actually doing justice to the marks. Now what happens is a lot of times you see that marks 5. See, if you give an online exam, the maximum mark that can be given for a particular question is 5 marks. Okay, so if you do it, it's going to take time. If you remember the result, you can use the result directly. Okay, but then sometimes it's good to actually explain it, because please always remember this. I don't know if when in your undergraduation or in your 11 12 your teachers have taught this or not, but for me what is important is when you write down an answer in your exam, you should understand that the teacher knows nothing at that point. Okay, it's not that, oh, the teacher knows this, so I'll just directly write this. Okay, so that's not the aim of exams, right? Sadly, that is the education system that we have in India. Okay, so that is what you have to write. Writing part should be such that it should be self-explanatory. Even someone doesn't know that topic, he or she should be able to understand. Of course, he should know the maths, but then the steps should be clear so that your marks that have been given to you should be, you know, do justice to the marks, the answer, length of the answer that you have. So always remember that you are explaining it in such a way as if you are explaining it to a student in a class, okay? And that's the way that you should write down in your exam. So I told you, I think this example also, I've seen many students, okay, they're very good, they clear exams, okay? But you know, most of these exams which we are actually going through are all multiple choice MCQ types, okay, objective types. So the aim is actually not to see the steps. The aim is what is the final answer that you have actually got, okay? So that's fine in a normal conventional way of giving entrance exams, but that's not fine when you write down answers for, you know, the universities or the institutes. Okay, so it's important that you actually be explanatory, and that actually helps you to become a better teacher. When you write down your steps, explain it better in the future. If you're a teacher, okay, you'll be able to explain it to your students better. But if you just jump steps, okay, you know, it becomes very difficult. I don't know if you have followed lectures on NPTEL. You must have, okay. Even in undergraduation level, also there are so many lectures which you can actually check. So if you check those lectures, you see a lot of lectures, you know, faculties and all might be from IIT, but then the steps that they are doing, they are not explaining everything. and every student doesn't have the same pace of studying. Okay, it's very important that we do it, and we do it for our own satisfaction. When we do it, we'll feel that okay, this should be correct more or less. Okay, so that's important. Okay. Anyway, let's just do it. Okay.
Sir, I have seen, sir, I have seen the photo in chat box. Sir, can you please see that
You sent a photo in.
chat box?
Okay, check. Okay, let me check. Before that, let me just do it. Okay, let's just finish this off.
Okay, sir.
So this is 1 by pi, and then you can take pi. I'll just take this function now. Okay, and then this will be 0 to pi cos of this one is something which I have not done in my copy. Okay, so even I don't know. Just check. Okay, the steps. It's correct or wrong. And this is 1 divided by pi, and this will be x cos of mx dx. Okay, so we have not done that cos of mx dx. So maybe someone can help me with the answer with this. So this is pi gets cancelled. This will become sine, and then this will be 0 to pi. So straight away I'll write it as 0. Let me not take too much trouble here. 1 divided by pi. Okay. This one. Okay. Integration by parts maybe again. Okay. So this is x and sine of mx divided by m. Okay, and this is 0 to pi, and then this is a minus, then we do a cos, we take sine of mx by m, so then we do sine, so it will be 1 by m square, and then we do it sine, so that will be plus. Okay, yeah, this should be plus. I think that's correct. And then we have got cos of mx. So if you do it in the similar way what we have done last time, I think this is something which you should get. I sometimes get confused with the signs, so it's very important that we remember the signs and all. Write it correctly. So this should be. Wait, let me go. Now this is sine. Okay, minus of 1 by pi, and then this is pi sine of mx or whatever. Okay, we got 0 again. Okay, so this should be 0 sine. And this is 1 by m square into cos of pi x minus 1, right? Cos of 0 is 1. So we can write it down as minus of 1 divided by pi m square, and this is cos of pi x. So the answer that you all are getting, it seems there is some problem there. I don't know, I may be wrong.
That's the answer.
Can you all confirm if I am wrong or you are wrong?
Yes, sir, that's the answer I got.
So just check that. No? It seems that the BI is a little bit which is bothering me. Okay? I'm not saying I am wrong. Just yeah.
Sir, I got the same answer, but sir, if we take the odd function, we can.
Yeah. So as I said in the last problem also, we really did not consider the odd function or the even function. We have just kept the general form.